Hi all, today we're gonna start with Unit 6 Utilities, treating the way that we heat and cool industrial processes. Utilities are the responsibility of the technical staff designing or retrofitting the plant. This staff must select the most suitable type for energy utilities to choose if you're gonna use steam or flue gases from a turbine. Also, select the levels if this steam gonna be 1 bar G or 6 bar G, or the flue gas is gonna go out of stack at 120 or 100 Celsius. And finally, with type and level, to dimension it, knowing the heat flow or the cooling flow that you will need in your process for your utility. Each utility has its own characteristics. First, the size of the utility, of the type of utility, the mass, the volume, or energy flow stability, that can be very different. Is very different the amount of energy that a big turbine can produce. Very different from a small organic Rankine cycle. Each type of utility has also its level variation pattern. It is the temperature at what the heat is given can change in very different way. It can be isothermic or with a sensible heat changing temperature. And it's also different the capacity to combine with other utilities when several are needed. These differences make some type of utility more suitable for some process or for others. Typical cases in which we have to design utilities is, for example, the change of a spoiled or damaged utility device. The steam boiler has broken and we have to change it. Or when a revamping or a debottlenecking of the plant is in course. In these cases, big, expensive changes gonna take place and is a good moment to optimize, change our utilities. During this part of the lesson, we're gonna talk about the most frequent, the most common utilities in process, dividing it in heating and cooling. The most common utility for heating in our process, is steam. Low pressure, medium pressure, high pressure, from a steam generator, a boiler, or from a heat recovery steam generator, the flue gases of a turbine or engine that enter a heat exchanger for recovering heat. It can come also from steam generation through cogeneration. It is after being used to produce work in plus of heat. In next slide you can see a complete steam system. Here, boiler feed water cold, take heat from the process, that is cooling, to enter a boiler, a steam generator. This boiler produces steam at different level, low pressure, medium pressure, using fuel and air as feed. In this example, these two first level are used to directly heat the process, and an upper level steam, high pressure, makes a jump through a turbine in order to produce work. This is cogeneration, and the outlet at a different level is used to directly heat the process. A steam system can be very complex, having several levels. Another heating utility are using directly the flue gases from a gas engine or a turbine, which is called topping. Here you can see a gas turbine using the flue gases at the outlet to heat directly the process and produce shaft work. In this example, also part of the heat from the flue gases is used to produce medium pressure steam to heat the process. This is also a frequent practice. You can find also thermal fluid or thermal oil systems, where the heat transfer medium is a compound heat-resistant heated in a boiler and taken to the system to heat some stream. After that, it comes back to the boiler to be heated again. Finally, for high inputs of energy and high levels of temperature, you can use furnaces, where you can use the heat directly from radiation or from the flue gases from convection, and you can take heat that is cooling to preheat the air and with fuel produce the combustion using the radiating part of it and the convecting part of it. For cooling, the most common system is cooling water, with or without a cooling tower, if you don't have sea or river water to use directly. In the scheme, you have heat going out the process to the cooling tower, and finally to the atmosphere. Depending on the level, for higher temperature, you can cool your process using an air-cooled heat exchanger. It's very used in condensers above 70-80 degrees Celsius. This symbol is normally used for air refrigerators. They need a lot of space and being in a clean, high level to get fresh air, and are regulated through the blowers that pass the air through. If you must cool things to a low temperature, you can use subambient low temperature refrigeration, normally using vapor compression or vapor absorption. When using vapor compression, it's a very expensive utility because you must give power to the process. And vapor absorption is much less used to recover low-level heat from the process. Here you can see your freezer, your low-temperature vapor compression system taking heat at low temperature from the process and sending it normally to the cooling water utility and to the cooling tower. As cooling, you can also use boiling feed water preheating or combustion air preheating. We have seen it before in the scheme. Boiler feed water preheating, air preheating. And also steam generation. If you have heat at a high level, you can produce directly heat, recovering heat from the process. And much less frequent for recovering low-level heat from the process, bottoming organic Rankine cycles cogeneration. These work exactly as a normal Rankine cycle, but uses an organic compound, low-level evaporating one, to produce the vapor that is used in a turbine and recover work from that. Finally, heat pumps are something in the middle because they produce at the same time heating and cooling. In the scheme, you can see a heat pump taking low-level heat from the process and giving to the process higher level heat, but the difference between both in temperature is not very wide. Sometimes a very good solution. And with that, we finish this introduction and description of the most frequent utilities.